This is a robot farmer.
Until recently, building a robot with the same capability has been almost science fiction.
We came to the UK to see a robot that can do something totally new. It can pick soft fruit, like strawberries. Now, there's already a lot of automation on farms, GPS-guided tractors, for example, but nothing quite like this.
Here we're trying to position something very delicate and small. We can move to anywhere in 3D space, and we can approach that point from any angle.
If you want to keep the strawberries intact, you need something smart and dexterous, which is what these robots do. Why do this? It turns out it's getting harder and harder to find the human labor we need to harvest all the strawberries made in a place like this huge, fancy strawberry farm.
The cost of fruit wasted last year in the UK, purely because of our inability to recruit enough pickers, was about £35 million. That number is forecast to double again this year. For me, this is a catastrophe, and robotic automation can help enormously.
And as these robots get smarter and more dexterous, they can do more than that. They can actually help us rethink everything we know about physical labor.
It takes a lot of effort, intelligence, and bloody-minded perseverance to make it all work.
This is Hard Reset, a series about rebuilding our world from scratch.
Farming is probably humanity's oldest industry, but increasingly we're having to rethink all kinds of things.
This is Duncan. He is one of the co-founders of Dogtooth, and his background is in farming.
So my background is not in agriculture at all. My background is in machine learning and computer vision.
Oh, well, the idea for Dogtooth came to Duncan while he was on a farm.
I was sitting on a beach in Morocco.
Well, goddammit.
Morocco is an incredibly beautiful country, but it is covered in litter. And it just struck me that knowing what I knew about computer vision and machine learning, actually the problem of identifying the litter on the beach using cameras was largely solved. What we needed was a low-cost robot that could crawl their way around the beach and pick up all the pieces of litter. That underlying thinking took us in a slightly different direction.
It took them to a farm. Hey, third time's the charm.
Yeah.
This is Ed, Duncan's co-founder, and he's going to show us how the robots get built.
Welcome to Dogtooth. This is our R&D workshop. Our robots are made up of a few different technologies, if you like, electronics, mechanical, and software, and they're all brought together with bits of firmware, and this is where most of our integration work happens. So here you'll see our clean room. This is where we do all of our electronics integration work.
In order to make the robot work in such a dynamic environment like a farm, the folks at Dogtooth couldn't use a lot of off-the-shelf technology. They practically had to make every part of this robot from scratch.
So this is our commissioning area. So on the right here, we do arm commissioning.
This robot arm, how much of this is custom designed by you?
All of it, unfortunately. This is all of our stuff, yeah. These arms here are in different stages of commissioning. The ones without any covers are on their initial test. So once it's done its initial commissioning test, it gets its covers put on, and then it will run through a burn-in test, and that takes about 16 hours.
So this is like C-3PO in Phantom Menace, and then this is from A New Hope.
There you go. I've never seen Star Wars.
What?
I know the reference where it's from, but I don't know Star Wars, I'm afraid.
Oh my gosh.
Like the Star Wars movies, robots are not new. They've been around for decades, and there's very little excuse for not having seen them. But unlike C-3PO, robots in the real world could only work in structured environments with very tight tolerances. In other words, nothing like a farm.
Is this like driving with a PlayStation joystick?
Exactly right, yeah. So my wasted teenage years weren't so wasted.
See, Mom?
So this is one of our 4th generation robots. The nice thing about our arms is they are super flexible. It's got 6 degrees of freedom, and at any given joint, the actual ability of the arm to rotate way more than 360 degrees. In this pick ahead here, you'll see a pair of cameras,
right,
and a bunch of LEDs. The LEDs allow us to pick at night. The cameras allow us to see the fruit in 3D. And in the center here, we have our inspection system, where once we pick the berry, we can suspend it into this chamber. Got cameras, so we can view the berry all around, nice consistent lighting, pick up 17 different types of defect. And so we know whether to put it into a waste chute or into a punnet ready for retail.
What do you guys call them?
Punnets.
Punnets?
Yeah.
You guys have crazy names for things.
I think in the US they're clamshells, right?
That sounds right.
Yeah.
Yeah. or just the box your strawberries come in?
Yeah, sure.
Yeah.
So here's our polytunnel. We put this up about 3 years ago, and we're actually, it turns out, all right at growing strawberries. For a bunch of engineers, we're going all right.
So the first question I have, as someone from the United States, I've never seen a strawberry farm this at arm's height.
Yeah.
This right all the way already feels like a better design just from a picking standpoint for humans.
It absolutely is.
Here in the UK, we tend to use quite modern tabletop growing systems, approximately the right height to make it easy for human workers to pick the fruit.
Obviously about the robot is it's got to be super rugged. We're here on a nice flat farm in the middle of Cambridgeshire.
Right.
We also operate these on very steep hillsides when it's raining cats and dogs and there's mud everywhere. So we've got super rugged tracks. Moving on up, you've got the 2 robot arms which are doing all the clever bits.
The arms of the robot have these stereo cameras, and they use computer vision to navigate this complex environment, find a stalk, and gently remove the fruit.
So welcome to the glasshouse. Up here, you'll see us starting to run robots. We've got 6 running today, I believe. What we're essentially doing is just looking for clean lines along which to pick so that we're maximizing our chance of getting our target berry. Once I've got a clear vector to the stalk that I'm interested in, I'll pick along that vector, grab a stalk, grip and cut it, and then I'll take it to the inspection chamber here. You'll see a few flashes as it images it all around. Then it will decide which punnet to put it in.
Well, it's interesting because on this one, it looks like it picked the right berry. It just was attached to the
Yeah,
wrong
so
one.
you'll see here, it just picked a little bit high, and so it got another berry in with it.
Right.
Pick that up in the inspection chamber, and so it's put it into a punnet here for a supervisor to sort through it, pick up the good berries and leave the bad berries behind.
Just to be clear, this robot won't mean the end of humans on farms, so there will still be plenty of dating profiles on farmersonly.com.
The dream, I think, is that robots can perform some of the dull tasks and allow us to focus on the things that we as human beings are uniquely good at.
So here at Dogtooth, the goal isn't to replace human workers, but the workforce for something like strawberry picking, which is a seasonal job, it's very difficult to make sure that we're getting enough workers across the UK. So the way that we view it is that the robots we can create will be very good at doing a very specific task. For us, we look to incorporate our robots with human workers so the humans can do the thinking that the robot can't.
For now, humans will supervise teams of these robots as they harvest berries. And the robots, for now, are a bit slower than the humans at picking.
How long does it typically take for one to finish a row?
Depends how many fruits you have in that row.
Okay, fair enough.
One of the things that we haven't prioritized yet is making them go faster.
With these robots, we've gone for the slow but steady approach. The kind of maximum speed that we have around these robots is about a quarter the speed of an average person. The next generation we're working on will be more like half the speed, maybe even more like 3/4 of the speed of a person. But because they can run for multiple shifts in the day, they're able to pick off just as much fruit as a person can over the course of the day.
Another interesting difference is that these robots don't grab the berry itself. They pick from the stem. This has the benefit of making the robot a little bit less complex, but mainly it avoids the problem of bruising and prevents the spread of fungus or other pests.
So as someone who buys a lot of strawberries, how do I know whether or not it's been picked by a robot?
On the end of each stalk, and you can see this one which has just been picked here, there's a little crimp mark just below the top, and that's where it's been held onto by the robot.
Ironically, these robots were made to supplement a dwindling migrant workforce, but now they themselves are a migrant workforce.
So these are designed to work out of shipping containers. We've currently got 16 of these in a shipping container on their way to Tasmania.
These robots spend part of the year in Australia, but it's far more affordable and environmentally friendly to ship robots to Australia than humans. And believe me, no one knows more about how expensive it is to ship humans to Australia than the English. Robotics will make it profitable to grow crops in more places, closer to where they're consumed. And that will reduce the carbon impact and make delicious, fresh produce available to more people.
Yeah, I was talking to some farmers yesterday about, whether this, robotics was a revolution or not, and I was saying it's not a revolution, it's a transition. If you look at it now, the difference between a modern farm and a farm 150 years ago is huge. But that didn't happen overnight. We're just at the start of really applying this kind of idea of intelligent robotics to real-world, tangible problems, and it's a really exciting journey we're all on.
Very cool.
So picture a scenario where robots are involved in harvesting all of our produce. The economics of food production would be totally different. Robots like this wouldn't just address labor shortages, they'd address food shortages by allowing precision agriculture in places where it just wasn't possible before.
I don't think most people realize how big of a problem food waste is.
It's 40% in the UK. We throw 40% away of fresh produce. It's nuts, isn't it? Yeah. So each robot is also going to be harvesting about 40 gigabytes of data every day. We're now working at building that together with weather forecasting into a yield prediction model where we can tell the future and understand not just what's ready to pick today, but what will be ready in 2 weeks' time.
And the intelligence that allows a robot to work in an inconsistent environment like a farm will eventually develop into the kind of intelligence that enables them to work in other dynamic, inconsistent places, like stores, hospitals, or homes. In theory, there's almost no physical job a robot couldn't do. So where does that leave humans?
I think the hope is that automation will allow us to create more desirable jobs for people. But I think there is also a threat. The danger I see is that we use robotic automation to displace people, to rob people of the opportunity to earn a livelihood.
Intelligence applied to robots has the potential to completely change everything we know about physical labor. If we do it wrong, it could cause the greatest labor disruption in human history. But if we do it right, it will free up an even greater source of adaptable intelligence with the capacity to shape the world. Us.
I think the interesting observation is that we're teaching robots to perform functions that we as human beings find really easy. As people, we are remarkably good at performing what are actually incredibly complex tasks. It should make us celebrate the beauty and capability of humanity.
I'm from America. What's a kilo?
A kilo is half a pound, 2.2 pounds to a kilo.
I only use metric system when I'm buying drugs. So, never bought a kilo of drugs, just to be clear.